Here's some more details about infrastructure as a service. We have 5 dominant systems, of which probably OpenStack and OpenNebula are the largest at the moment. CloudStack is similar to OpenStack but broke away. Nimbus was the first system. Sorry, Eucalyptus was the first VM management environment. It's no longer quite as active. Nimbus came along and was very valuable for several years. It's probably merging with OpenStack in the future. And you put this software on your own cluster, and then, or somebody does it, somebody puts it on their own cluster. So it's not like Amazon, which has their own proprietary software, which do this management of the VMs. So there's VMware, which is the commercial version, which is similar to the open source versions, but presumably has better support, possibly greater robustness. But active open source efforts like OpenStack have a pretty dynamic world. And the fact there were 2,800 in the 2013 OpenStack meeting, 2,800 people. So this is not a trivial field. And Eucalyptus has open source and commercial versions. OpenStack is itself solely open source. I'm sure many companies, like in fact CloudStack, will tend to build on top of OpenStack and offer commercial robustifications and customizations. If you were in Europe, you will be using OpenNebula, which is the dominant open source one in Europe. Here we have a picture from Microsoft. A platform as a service is where you develop applications, and it's the fabric on which you build. So here we have actually what we saw in an earlier slide, the VMs, then we have the data and the compute, then we have the platform living on top of this, interacting with these VMs and also with the fabric. The users come along over the internet, and you develop the application on top of this platform as a service. Where, as you say, you don't actually, at the platform level, you don't manage the VMs. That's done for you at a lower level. Here's a little comment on Amazon, which actually started off as just infrastructure as a service. And then along comes maybe a couple of years ago, you got this. These are when I went to my Amazon page, I had these things listed as my capabilities. Then about a year ago, it became this, 4th of March 2013. Hit the ground because Amazon keeps adding more and more capabilities. That's what I mean by saying Amazon is becoming more and more platform as a service. Here's the original things, EC2, that was the first announcement. The next announcement was S3, the storage service. And then all these other ones have come along. Either things like auto scaling, which is, if you like, a feature on top of EC2 to scale up capabilities. Dynamo, which is a nice NoSQL database, is just, if you like, a service offered on top of Amazon for data management. And here we have some topics that I listed, trying to describe what happened in clouds and what happened in grids. Grids did a lot of work on authentication and authorization. It built a lot of workflow. It did a lot of data transport. Grid FTP is a famous thing there. That's now called Globus Online. The software as a service model, although it's dominant in clouds, actually came equally well in grids. Relational databases came a long time before grids or clouds, but it's still critical. Program libraries where you store images and program material, that's critical in clouds because you want to store not actually the software for the applications, you want to store the whole image. So image management is critical for clouds. Blob is the basic storage for clouds. Did not really exist in grids. It's a so-called object store. You don't even think of them as files, you think of them as objects. That's S3 and Blob. Here's what I call data parallel file system. That's what Hadoop does with HDFS. It's the Google file system, and it's what Cosmos is Microsoft's data parallel file system used by Bing and their commercial Hadoop, the commercial ReproDuce systems. Table is a NoSQL construct, is simple DB and Azure table. You can view this as a scalable distributed Excel. There are various versions of this, what I call big table and little table. These are little table, tend to be small amounts of data. Google Big Table is an example, which is available as Apache HBase, which is large amounts of data. Queues, publish, subscribe, well-known messaging-oriented middleware. Very, very helpful. You should use queues wherever possible. Azure introduced this interesting concept of roles, which were essentially customized images to do certain important broad features, and it's implicitly used in earlier grids and earlier clouds, but it was only really popularized by Azure. I think they should get more credit for introducing this concept. I think this concept of roles is a pretty important idea. So you have a web role, which is an image customized for using web-facing services. And if you like, that's how you build portals in the grid language. Of course, we all know about MapReduce and its extensions. That's a critical feature of cloud technology. So these are just some examples of the richness of clouds and try to distinguish what clouds bring to the table or need. It's not just that they enable this to be invented. Some of these things are essential. Without them, you couldn't have a cloud. You need a program library or you won't actually have a possible cloud that would work. So that's the end of that lesson. Next lesson describes how to do data in the cloud and with some specialized remarks. And I recommend we move on to that next lesson. Thank you very much.